All right, in this video I want to do a little bit of review. We're going to talk about methods some more, and we're also going to talk a little bit more about special methods, and I'll end with a coding example. And for this I have a little piece of code. I'm going to ask you some questions about it. And after I ask a question, just pause the video and think about it until you think you have an answer, and then replay it again, and I'll talk about what I think the answer is. So here I have here I have a dog class, and I have the net method, which is giving the dog a name, and so this is a constructor such it's automatically called when a dog is created, and I'm just setting the dog attribute name based on whatever it's passed in. I have a method here that does the actual speaking or barking of the dog. It's going to bark some number of times. And then down here I'm actually creating two different dogs. And so down here I have three different ways that I could call the bark method with varying number of arguments passed in. And so the question is, if I get this type error, three positional arguments but four were given, or it takes three positional but four were given, which of these three was causing that? So I'll give you a moment to think about it, and then I'll walk you through it. Okay, so I'm going to assume you unpaused and we're back. And so let's first look at this 3. It takes 3 positional arguments. And is that true? Well, let's see what we have here. So this is the 1, this is the 2, and that's the 3. Those are the 3 positional arguments in question. And so what about this? How did we have 4 given? And the answer is number 2, right? It's this right here. How do we get to that? Well, here I have 1, 2, 3, and 4. So even though it looks like there's 3 here, I need to count what's before the parentheses. So just be careful when you're getting these error message, right? It says there were 4 given. Don't keep staring at it and saying, oh, I only passed 3. Make sure you count that 1 kind of at the beginning as well. Okay, so that's wrong. Next question is, which of these is right? And of course, we know this one is not right because we already talked about that. Well, the first one has exactly 3 arguments being passed in. It's 1, 2, 3, exactly what we were hoping for. Okay. Take a moment to think about this very carefully, right? It's a bit of a trick question. But what prints when I run this correct line of code of these 3 options below? Okay, so well, what happens here when I say Fido.bark? Well, it's going to put these arguments in like this. So Fido is going to go to self, 5 is going to go to multiply, and then false is going to go to uppercase. And so what does that mean? That means that Fido is a variable that's going to refer to an object, and self is really just a special variable that's going to refer to that same object. So, well, what is that object? Well, that's, Fido equals the dog named Sam. That's kind of the trick part. And so I'm just going to kind of clear all this off and go to the next slide. If you were running this in Python Tutor, you would see something like this. At the moment that we enter the bark method, you'll see that the self variable inside of the bark method is the same as Fido in the global namespace, because we said Fido.bark. And so then of course it's trying to get the name Sam there. And so well, what is the final answer? So I guess it's just this one, right? That's the only one that does Sam. And then we're also doing lowercase, so we have that. Okay, so I have just a couple more questions here. Special methods. Well, what is a special method? Do they get called explicitly or implicitly? And the answer is that special methods are the ones that get called implicitly. For example, let's say I say something like this, x less than 5. It doesn't look like I'm calling a method, but I actually am. The method I am calling is underscore underscore less than underscore underscore. Right? That's an explicit, that's a special method. the explicit methods are examples of like, well, the bark method or something like that. So special methods by definition get called even though it doesn't look like we're calling them. Okay, second, what does print use to represent an object? And the answer is it uses stir. So when we're printing things, that's usually meant for a user of the program, not necessarily an actual programmer. And so the stir is what's kind of traditionally used for that. These other two, repr and HTML repr, are for things a programmer might look at. And that's where you're going to get, at the end of a cell. If you put that there, you're going to see the repr. And so, either with this regular repr call, maybe I'm just doing some sort of string representation that gets output. With repr HTML, there's a lot of flexibility. It could be like an HTML table. You get that with a pandas data frame. Or maybe an image. You get that with a plot. So lots of flexibility there. Okay, last question. What special method must you implement for sorting to work? Which of these four? And the answer is less than. If I want to do something like, if I want to be able to run code like this, where x is some object of kind of my own type, if I want to run that, I need to implement this method, right? This one really kind of gives me multiple things. It lets me do x less than 5, and then it can also, if I have a list of these objects, I can say, l.sort, and it will use that less than comparison for that. So if you just care about sorting, then in that case, then the less than LT is the only thing you care about. If you kind of care about other comparisons in general, then you have to implement greater than or equal to all the other goodies inside of your class. Okay, so I'm going to head over here to my notebook. And let me see, did I do that correctly? Yes, I switched. And I want to talk about how we can use indexing and kind of make it a little bit more flexible. So here I just have a regular Python list, L, and I have these values in it. And if I look at position 2, I get 100. Position 3, I get 200. Pretty intuitive. And as you all know, if I put in a float like 2.5, it complains. Now, you could imagine that if I put something like 2.5, wouldn't it be kind of cool if it took something like halfway between these two values? You could imagine that it would be kind of a cool feature if I got 150. Or if I did this, maybe I would get 130, right? So Python lists don't do that. As you can see, I'm getting that error. But now that we learned about the getItem special method, I can do that. And so kind of a common thing that you might do is you might have a class, and I'm going to call this continuous list. You might have a class that just wraps another data structure, right? So I'm going to say L. And by wrapping, I mean that I just have an attribute inside of it that is really kind of containing that list, right? So well, what am I going to do here? Maybe I'll say something like CL equals continuous list of L, right? So I'm going to do that. And then the idea is if I want to look up continuous list of this, I want to be able to do these things. And normally when I'm kind of doing indexing in the traditional way, the continuous list, which is one of these, will just look in L like normal. If I do some sort of indexing like this, I want my continuous list to get some sort of average between these values, right? So let me just try and run this. And it says that my continuous list does not support indexing, right? And the reason why is I haven't implemented this method yet. I haven't implemented the getItem method itself, and then I'm going to pass in an index. Okay, and so maybe as a first step, since I'm wrapping, right? So if I, in my class, get an index, so I'm just trying to use that as an index in here, right? So for now, maybe I'll just say this. I'll say self.l of index. Whatever I get, I'm going to pass along, right? So let me kind of run this. And so these things work the same, right? Do you see what's happening there? When I run this piece of code, it's like, well, CL is a continuous list, and so this is actually a method call here, right? So I'm passing in 2 to index and my continuous list to self, right? So self is my continuous list, and while I have this L, which kind of refers back to the thing I set it up with, right? So I'm just kind of calling that in the thing beneath. So I can make it work the same way, and of course I haven't done anything fancy to deal with this yet, right? And so to deal with that, what do I want to do? I first need to get the values to kind of compute this. I need to get the values at index 2 and then 3, and then take some sort of interpolation between those. And so I need to be able to round this up, and I need to be able to round it down. And so what I'm going to do is I'm going to say from math, import upper and lower. And let me just try and make sure I know how these work. So upper of 1.2 and lower of 1.2. And why is that not working? Oh, I'm sorry. Upper is the ceiling, right? A ceiling is above us, and the floor is below us. My apologies. I shouldn't go from my memory, I should check my notes. And I see, well, if I round 1.2 up, I get 2. If I round 1.2 down, I get 1. And so I can do that with that index here, right? I can say something like index 1 equals the floor of my index. Index 2 equals the ceiling of my index. I'm going to round that up and down. And I guess for now, maybe let me just kind of do my lower index. So this will just run, and let me clean this up a little bit so you can see more. And what I see is that right now, if I put in a float, it's at least not crashing now, but it's just kind of rounding 2.3 down. Okay, so what I'm going to do now is I'm going to get the two values. I'm going to get value 1 equals self.l of index 1, and value 2 will be self.l of index 2. And then I need to take some sort of average of these, right? So I think that, well, maybe what I'll do is I'll actually just figure out what the difference between these two is first. How much bigger is value 2 than value 1? Okay, so I think what I'm going to do is, well, first I'll kind of return as if I'm rounding down, right? So this is the position at value 2, and then I want some portion of this difference, right? So I want some portion of this difference, and I need to multiply this by something, right? Kind of what I want to do is, well, if this is like 2.1, then I only want to have 10% of the difference added on, right? So I want 0.1 there. If this is something like 2.9, well, then I want to add 0.9 of this. I want to kind of capture most of that difference between these in, right? And kind of above and beyond value 1. And so, well, what is the exact formula here? It's, well, whatever my original index was minus index 1, right? So that will get me like the 0.1 or the 0.9. So I'll say index minus index 1. And let's see if this works. And it works beautifully, right? If I say 2.5, well, I get 150. That's great. That's in between these two. If I say something like 0.5, well, let's just think about that. I guess that will get me halfway between 1 and 3. So hopefully this gives me 2, and it does. And if I say something like 0.001, that should be very close to 1, right? And most of the way there, I'm going to interpolate. And so you can see that you can do very fancy things, right? Once you can use getItem, you can, for example, add interpolation to a list and kind of build features that Python doesn't automatically come with.